My name is Andreas Merschen. I'm a research scientist at the Center for Bits and Atoms, and I lead what's called the Label-Free Research Group. My background is in physics. I went from cosmology to theoretical physics to quantum biophysics, and now the group is called Label-Free because we end up doing so many different things that it didn't make sense to have a specific label. And that ends up being actually quite good because it demolishes the walls between the disciplines and allows us to not think about what field we're in. We just do the good research and then we find out what field it was in. Or perhaps sometimes we'll invent our own fields. So there's two different things. They are related in the sense that when I first came to MIT about 14 years ago, the mission was take a BioSolar cell that had already been created, meaning that it's a photovoltaic, it's something that generates electricity from the sun, but it uses dead green stuff, dead grass clippings, agricultural waste, things like this. The task was make this thing efficient. So I spent some time doing this with a team of people, and we managed to increase the efficiency by 4 orders of magnitude, which tells you how bad it was to begin with, since the efficiency can only be up to 100%. And in doing so, we became sort of very famous about being the guys who are making electricity out of green stuff. And then some company from Massachusetts came up to me in a social event, and they said, hey, we're being made fun of because we have this patent on harvesting energy directly from trees, but we don't know how to explain it, and you know, people think that we can power cars with it, and we don't know what's what. So I said, okay, fine, come, let's bring it here and let's look at it and demonstrate it. So when they demonstrated, we found out that it wasn't really up to the task that they had described originally, but the interesting part was that we couldn't figure out where the energy was coming from. So I hired a student, and over the summer we figured it out more or less, and then it became a big deal because people wanted to use it, to use tree power to power fire sensors for the United States Forest Service and the Bureau of Land Management. So that was a lot of fun. It culminated with us being given 400 acres of research land to burn. And we burned it, and our sensors survived, and as far as I know, that's in the market now. I mean, we disengaged as MIT because the research was done. So it took some awards, this product became quite famous, and as far as I know, this ended quite a few years ago. It was quite successful. I was trying to figure out how to bring my piloting state into the office. I happen to be a pilot as well as a scientist, and when I'm flying my plane, my brain is very clear. I don't make any mistakes. The proof is that I'm still here. And it's a small plane. If you make any mistake, you're probably done for. And it's a very particular state of flow that you have. Now, the state of flow is identifiable by EEG, which is electroencephalograms. And there were available sensors, and we built some ourselves, that you could put on your head without a large number of wires that can record your state while you're flying the plane. It ended up not working quite as well because in the small plane at least, you have big headphones, you have to move your head all the time, so that interfered. The next best thing was, that I know of, how to get myself into this kind of flow state, was to drive my motorcycle real fast. Now, I got 2 children now, so that has some safety implications, and you know, renting a racetrack and ripping apart helmets was a little bit of a production, so I thought, what would be the first thing to do to make sure that our algorithm even is going to work? So we tortured some students, and we asked them to put their hand in cold water to induce pain. And it turns out that cold water for humans induces pain quite quickly. In about a minute, your whole arm is in pain. And we measured that with this toy device, essentially, that is available commercially, that we reprogrammed to behave better than the best hospital tests out there. So in doing so, we completely by accident invented the world's first portable, wearable, practical pain detector. This was back in 2015. And it took us a couple of years to figure out what we'd done. We didn't realize that that's what we had done. So Mind Booster came about when this patent became available for licensing, and they took it to create brain-computer interfaces and to create neurofeedback games that eventually tend towards thinking your cancer away, thinking your pain away, thinking your immune system into action. We know from lots of years of research, we're talking maybe 4 decades now, that neurofeedback as well as training and meditation and things like this can allow trained people to regulate their core temperature, to regulate their heart rate, and we're talking about 20–30% differences, which are significant. To regulate your core temperature up by 7 or 8 degrees, that's incredible. That's like a very high fever. And to do it on demand, that takes about 20 years of training or some kind of a neurofeedback game that we're developing with Mind Booster. That's what the interesting part is. It is the beginning of an era, I believe, in how we're doing human performance enhancement using neurofeedback games, and using EEG signals, using other things that tell us what their body is doing. And by externalizing them and feeding them back into ourselves, we are allowing conscious control over some autonomic system functions. And that's compelling. We're talking bypassing the whole planting an electron inside of your deep brain and doing it instead by playing on a screen on a smartphone. Regulating your pain consciously, thinking your pain away, taking your attention away from the pain so you don't feel it as much. Things like this are now within grasp, and the hardware is no longer the issue. It's now about the software, and MindBooster is doing the software.